Hello everyone, and today we're going to have special type of continuous random variable, specifically the uniform continuous random variable. For the continuous uniform distribution, a continuous random variable x with a probability density function f of x is equal to 1 over b minus a for x is in between a and b inclusive is a continuous uniform random variable. For the mean and variance, if the random variable x is a continuous random variable over the interval from a to b, the mean or the expected value of x is a plus b over 2, and the variance, which is v of x, is equal to b minus a squared all over 12. Suppose x has a continuous uniform distribution over the interval from 1.5 to 5.5. Determine the mean, the variance, and the standard deviation of x. What is the probability that x is less than 2.5? Determine the cumulative distribution of the function. For letter A, for the mean is equal to a plus b over 2. So that would be 1.5 plus 5.5 over 2. So that is, so you may use your calculator for this. It is equal to 3.5. For the variance, the variance is from the formula 5.5 minus 1.5 squared. So that's 5.5 minus 1.5 squared all over 12. This is 4 over 3. If we want to solve for the standard deviation, this is square root of 4 over 3, which is 1.1547. For letter B, we want the probability of x less than 2.5. So for the probability, it is the integral of 1 over 5.5 minus 1.5 dx. Less than 2.5 is from 1.5 to 2.5. So that's a simple integration. So you can have that as 1/4 or 0.25. For the cumulative distribution, for capital F of x, it would be 0 when it is less than 1.5, and it is 1 when it is greater than 5.5. So f of x would be the integral of 1 over 4 or 1 over 5.5 minus 1.5 dx from 1.5 to x. So it would be x over 4. So with that limit, it would be in between 1.5 to 5.5. It would be x minus 1.5 over 4. For the mean and variance of a continuous random variable, examples, let the continuous random variable x denote the current measured in a thin copper wire in milliamperes. Assume that the range is from 4.9 to 5.1 and the probability density function of x is equal to f of x equal to 5. That would be 1 over 5.1 minus 4.9. So that is 1 over 0.2, which is equal to f of x equal to 5. So this is the density function. So if we are going to graph that, it would be a continuous random variable, a uniform continuous random variable. So if we want to solve for the probability that it is less than 5, so when you say less than 5, it would be this region. So less than 5 is from 4.9, where the density function exists, up to the upper limit 5. And symmetrically, you can determine that it is 1/2 of or 0.5, or you can use integration, the integral of 5 dx from 4.9 to 5. What is the probability that the current is greater than 4.95? So greater than 4.95 would be from 4.95 to 5.1. So the integral of 5 dx from 4.95 to 5.1 is simply 7.5. 0.75. For that same problem, for the copper measurement in 4.1, the cumulative distribution of the random variable x consists of three expressions. It would be 0 when it is less than 4.1, and it is 1 when it is greater than 5.1. In between, it would be the integral of 5 dx. So it would be the integral of 5 dx, where the limit is from the lower limit 4.9 to x. And this is evaluating that, it would be 5x minus 4.9 times 5, so that's 24.5 over the interval. So this is now the cumulative distribution. So it would be from 0, it would be 0 from 0 to 4.9. It would be the linear expression 5x minus 24.5 over the interval from 4.9 to 5.1, and it is equal to 1 when it is higher than 5.1. Suppose that the time it takes a data collection operator to fill out an electronic form for a database is uniformly distributed from 1.5 to 2.2 minutes. What's the mean and variance of the time it takes an operator to fill out the form? What is the probability that it will take less than 2 minutes to fill out the form? And determine the cumulative distribution function of the time it takes to fill out the form. So our f of x would be equal to 1 over 2.2 minus 1.5 for x is in between 1.5 and 2.2. So this can be simplified as f of x is equal to 10 over 7 for x in between 1.5 and 2.2. So to solve for the mean and variance, the mean is a plus b over 2. So 1.5 plus 2.2 over 2. So that is 1.85. For variance, it would be 2.2 minus 1.5 squared over 12. So b minus a squared over 12. So that's 0.0408. And the probability that it will take less than 2 minutes, so the probability that x is less than 2 is equal to the integral from 1.5 to 2 of 10 over 7 dx. So this is 5 over 7. So this is for A, for B, while for C, the cumulative distribution function, so we can have f of x is the integral from 1.5 to x of 10 over 7 du. So this is 10 over 7x u. For the cumulative distribution, so f of x is the integral of 10 over 7 du from 1.5 to x. So that's 10x over 7 minus 10 over 7 times 1.5. So that's 10x minus 15 all over 7. So f of x now would be 0 when x is less than 1.5. It would be 10x minus 15 over 7 for x is in between 1.5 and 2.2, and it would be 1 when x is greater than 2.2. So this is the cumulative distribution function. Suppose the probability density function of the length of a computer cable is 0.1 from 1200 to 1210. So for the mean, it would be 1200 plus 1210 over 2. So that's 1205. For variance, it would be 1210 minus 1,200 squared over 12. So this is 100 over 12. So for the standard deviation, it would be the square root of this. So that's 5 square root of 3 over 3, which is equivalent to 2.8868. For letter B, if the length of specifications are 1195 to 1205, what proportion of cables is within specification? So we're looking for the probability that X is in between 1195 up to 1205. So this is the integral from 1195 to 1205 of 1 over 1210 minus 1200, or you can have 0.1 dx. So this is 0.1x from 1195 to 1205. But you don't have 1195. So it exists from 1200. So we have here 1200. So that would be 0.1 times 1205 minus 1200. Note that it does not exist from 1195 to 1200. So we use the lower limit of 1200. So this is 0.5. For references, we have used the following textbooks.